to convert this into the simplest form of a plus ib, I'll multiply this with the conjugate of the denominator. We know that sine theta is positive and cos theta is negative in the second quadrant. So therefore, theta can be taken as pi minus the value. Cos theta, sine theta value is 1 by root 2 for pi by 4. So this can be taken as pi minus pi by 4, whose value is 3 pi by 4. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, let us continue the problem of complex numbers. So here, convert the complex number minus 16 over 1 plus I root 3 into polar form. So we know that we can convert the algebraic form of complex number x plus iy to the polar form as z is equal to r cos theta plus I sin theta by finding the modulus and argument of a given complex number. So before that, it has to be in a simplest form, in the form of a plus ib. So let us take here z is equal to minus 16 over 1 plus I root 3. Now to convert this into the simplest form of a plus ib, I'll multiply this with the conjugate of the denominator. So what is the conjugate of the denominator? 1 minus I root 3 over 1 minus I root 3. So now let us solve this. So we have minus 16, 1 minus I root 3 whole divided by, we know that previously I have told you if you have a plus ib, a minus ib, then it can be written as a square plus b square. Thus we can write this as 1 square plus root 3 whole square, which can be written as minus 16 into 1 minus I root 3 whole divided by 1 square is 1, root 3 whole square is 3, 1 plus 3 is 4. Thus we get z is equal to, on dividing it, we'll get it as minus 4, 1 minus I root 3. Let us multiply minus 4 inside. We'll get z is equal to minus 4 plus 4 root 3 into I. Now this is the simplest form in the form of x plus iy or a plus ib. So now let us convert this into the polar form. So we have z is equal to minus 4 plus 4 root 3i. We know that r is equal to square root of x square plus y square. So thus in the place of x we have minus 4 whole square is 16. Next, in the place of y, we have 4 root 3, which become 4 square into 3, that is 16 3s are 48. So, plus 48, you will get this as root 64. So, square root of 64 is 8. Since r has to be taken as positive, we will take r is equal to 8. Next, we know that x is equal to r cos theta and y is equal to r sin theta. So now x value is minus 4, 8 cos theta, y value is 4 root 3 is equal to 8 sin theta. So on solving this, we will get cos theta is equal to minus 1 by 2 and here sin theta is equal to root 3 by 2. We can observe that cos theta is negative, sin theta is positive. We know that sin theta is positive and cos theta is negative in the second quadrant. So therefore, theta can be taken as pi minus the value. But what is theta? We know that for cos, when it is half, then theta can take the value of pi by 3. Also sin pi by 3 or sin 60 degrees root 3 by 2. Hence I can take theta as minus pi by 6 or I can take it as minus pi by 3 or I can take it as pi minus pi by 3, which is equal to 2 pi by 3. So therefore, for the polar form, we know that z is equal to r, which is 8 cos theta, that is cos 2 pi by 3 plus I sine 2 pi by 3. So this is the fuller form of a given complex number. Next, find real theta such that 3 plus 2i sine theta divided by 1 minus 2i sine theta is purely real. When I say purely real, the imaginary part is 0. When I say purely imaginary, the real part will be equal to 0. So first let us reduce it into the simplest form. So we have here z is equal to 3 plus 2i sine theta whole divided by 1 minus 2i sine theta. Multiply with the conjugate of the denominator, that is 1 plus 2i sine theta divided by 1 plus 2i sine theta. So multiply the numerator. So we'll get 3 plus 6i sine theta plus 2i sine theta plus 4i square sine square theta whole divided by, so here it is 1 square plus 2 square sine square theta. So next we have here 4i square which become minus 1. So we have 3 minus 4 sine square theta. 6i sine theta plus 2i sine theta becomes 8i sine theta whole divided by 1 plus 4 sine square theta. Now by separating the real and imaginary part, we'll get z is equal to 3 minus 4 sine square theta whole divided by 1 plus 4 sine square theta plus I into 8 sine theta divided by 1 plus 4 sine square theta. When I say the given complex number is purely real, obviously the imaginary part should be equal to 0. So this implies 8 sine theta divided by 1 plus 4 sine square theta should be equal to 0. So this simply implies that sine theta is equal to 0. So we have learned the trigonometric equation. Sine theta is 0 for n pi values. So therefore here theta can be taken as n pi where n belongs to integer. So this is the value of theta. Next question. Convert the complex number z in the polar form. So first we have z is equal to I minus 1 cos pi by 3 plus I sin pi by 3. Let us substitute the value of pi by 3 in terms of cos and sin. So we have here z I minus 1 cos pi by 3 is 1 by 2 and I sin pi by 3 is root 3 by 2. Then it becomes 2 into I minus 1 whole divided by 1 plus I root 3. So this can be written as z is equal to 2I minus 2 whole divided by 1 plus I root 3. So multiply with the conjugate 1 minus I root 3 by 1 minus I root 3. So here let us multiply now. So we have 2I multiplied with this will get 2I minus 2 root 3 I square will get. So 2I minus I root 3 becomes 2 root 3 I square. Next we are multiplying minus 2. So minus 2. Next we have minus into minus plus 2 root 3 I whole divided by 1 plus 3. So here we can take 2I as a common factor here as well as here 2I. I square is minus 1 plus 2 root 3 minus 2 plus 2 root 3I whole divided by 4. So by taking 2 common factor here in this 2 terms, I can take it as root 3 plus 1 as well as I also we can take it as common factor. We will get the factor as root 3 plus 1. Next we have plus 2 as a common factor, root 3 minus 1 whole divided by 4. So dividing and separating these 2 terms, we will get z is equal to root 3 minus 1 by 2 plus I root 3 plus 1 by 2. Now this is what we will get. Now let's find out R. So we know that R is root 3 minus 1 by 2 whole square plus root 3 plus 1 by 2 whole square under the square root. So on solving this, the value of R is equal to 2. Next we can take x is equal to R cos theta, y is equal to R sin theta. So we have x is equal to root 3 minus 1 by 2 is equal to 2 cos theta, and y is equal to root 3 plus 1 by 2 is equal to 2 sin theta. So this implies cos theta is equal to root 3 minus 1 by 4, and here sin theta is equal to root 3 plus 1 by 4. So clearly this theta can be expressed as pi by 4 plus pi by 6, whose value can be taken as 5 pi by 12. So when you put theta as pi by 4 plus pi by 6 and substitute in any one of the equation, this is what you will get the value. So thus we can take z is equal to 2 cos 5 pi by 12 plus I sin 5 pi by 12. Convert the complex number z is equal to 1 plus 7i divided by 2 minus I whole square in the polar form. So here also we have denominator 2 minus I whole square. Let us express it. Then the z becomes here 1 plus 7i divided by 2 square is 4 plus I square is minus 1. Next we will get minus 2 into 2i. So therefore 1 plus 7i divided by 3 minus 4i is what I'll get. So multiply with the conjugate 3 plus 4i by 3 plus 4i. So on multiplying we'll get 3 plus 4i plus 21i plus 28i square whole divided by, so 3 square is 9, 4 square is 16. So on solving this, we will get the value as 25i minus 25 divided by 25. So we'll get z is equal to I minus 1. So next to find r here, we have a complex number here. To find r, it is nothing but x square plus y square here. So which is root 2, because value of x is minus 1, value of y is 1 here. So this is nothing but minus 1 plus I, that is a plus ib form. Next, we will find x is equal to r cos theta. So we have x is equal to r cos theta and y is equal to r sin theta. So therefore here we have minus 1 is equal to root 2 cos theta, 1 is equal to root 2 sin theta. So we get cos theta is equal to minus 1 by root 2. Sin theta is equal to 1 by root 2. Sin is positive, cos is negative in second quadrant, and cos theta, sin theta value is 1 by root 2 for pi by 4. So this can be taken as pi minus pi by 4, whose value is 3 pi by 4. So therefore, z is equal to root 2 cos 3 pi by 4 plus I sin 3 pi by 4. Next question, that z1 is equal to 2 minus I, z2 is equal to minus 2 plus I. Find the real part of z1 into z2 divided by z1 conjugate and imaginary part of 1 over z1 into z1 conjugate. First, let us find out z1, z2 divided by z1 bar. So z1 is 2 minus I, z2 is minus 2 plus I, whole divided by conjugate of z1 is 2 plus I. So here we have 2 2s are minus 4 plus 2i. Next we have plus 2i. Next we have minus I square whole divided by 2 plus I. So I square becomes minus 1. So minus 4 plus 1 is minus 3 plus 4i divided by 2 plus I. Multiply with conjugate. So again we have minus 3 into 2 minus I, which is minus 6 plus 3i. Next 4i we have plus 8i minus I square will get, which become plus. So therefore plus 4 whole divided by 2 plus 1. Next we have this as minus 2 plus 11i divided by 3, which can be written as minus 2 by 3 plus 11 by 3i. Now I have separated the real part and imaginary part. We need the real part, that is the real part of z1, z2 over z1 conjugate is minus 2 by 3. Now let's see the imaginary part. So imaginary part of 1 over z1, z1 conjugate. So that is imaginary part of 1 over, so z1 we have 2 minus I. So that is 2 minus I, 2 plus I. So we know that a plus ib, a minus ib can be written as a square plus b square. So this can be written as imaginary part. Let us solve this. Can be written as 2 square 4 plus 1 square 1. So we have imaginary part of the complex number 1 by 5. There is no imaginary part. We have a purely real number. So imaginary part of this is clearly 0. That is, imaginary part of this complex number is clearly 0. Next, find the real numbers x and y if x minus iy into 3 plus 5i is a conjugate of minus 6 minus 24i. See the product x minus iy and 3 plus 5i is equal to the conjugate of minus 6 minus 24i. So first let us multiply this. We will get 3x here. Next we have 5xi minus 3yi. Next we have minus 5yi square, which becomes plus 5i. So conjugate of this complex number is minus 6 plus 24i. Now separate the real and imaginary part. So we have 3x plus 5y plus I common, 5x minus 3y is equal to minus 6 plus 24i. So compare real to real. So we will get 3x plus 5y as minus 6 and imaginary part to imaginary part. So we get 5x minus 3y is equal to 24i. Now to solve it in the form of simultaneous linear equation, make any one of the coefficient as common. So just I'll multiply 5 here, I'll multiply 3 here. So what happens? 5 3s are 15x plus 25y minus 30. And here it becomes 15x again minus 9y. So here you get 72. Subtract it. Change the sign and subtract. So these two get cancels here. So 25 plus 9 is 34y. And here you will get the value as minus 100 on 2. So solving this, you will get the value of y is equal to minus 3. Substitute y is equal to minus 3 in any one of the equation here. We have 3x plus 5y is equal to minus 6. We have y as minus 3 now. So we have 3x minus 15 is equal to minus 6. We have 3x is equal to 9. We have x is equal to 3. So thus the value of x is 3 and y is minus 3. Next, if x plus iy whole cube is equal to u plus iv, then show that u by x plus v by y is equal to 4 times x square minus y square. So we have this equation. Let us expand it. So u plus iv is equal to x plus iy whole cube. Use a plus b whole cube formula. So we have a cube plus b cube plus 3a square b. So that is 3x square b, that is iy, plus 3a p square, that is iy whole square. So x cube, I cube is minus I, plus here it becomes 3x square y into I, and here we'll get minus 3x, I square is minus 1 y square. Separate the real and imaginary part. You have u plus iv is equal to x cube minus 3xy square, and here we can take plus I as a common factor. If you take, you will get 3x square y minus y cube. Now compare the coefficients of real and imaginary part. You will get u is equal to x cube minus 3xy square. Similarly, v is equal to 3x square y minus y cube. Divide this by x, then you will get u by x is equal to x square minus 3y square. Divide this by y, you will get 3x square minus y square. So add these two equations, you will get u by x plus v by y is equal to x square minus 3y square plus 3x square minus y square. So you will get this as 4x square minus 4y square, which is equal to 4 times x square minus y square. Hence, we have proved that u by x plus v by y is equal to 4 times x square minus y square. Next, we have find the number of non-zero integral solutions of the equation 1 minus x whole power x. But here it is given in terms of modulus. So, we need to find out the modulus of 1 minus I, whose value to the power x is equal to 2 power x. So, let us find what is the modulus of 1 minus I, which is square root of 1 square plus minus 1 whole square, which is root 2. So, therefore, 1 minus I modulus to the power x is equal to 2 power x. So, we will get the value as root 2 to the power x is equal to 2 power x. We get 2 to the power x by 2 is equal to 2 power x. So, since base or same powers can be equated, so we will get here x is equal to 0. So, what does they have asked us? Find the number of non-zero integral solutions. So, we doesn't have any non-zero integral solution because we are getting x is equal to 0. So, thus there is no non-integral solution. So, no non-zero solution. So, we can say no non-zero integral solution. So, because we are getting as x is equal to 0, we doesn't have any non-zero integral value for x. So, we will meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.